If a person is swimming in a swimming pool and a live wire falls into the water on the other side of the pool, the person can experience a shock, even if they are not touching any part of the pool concrete or railings. Electricity flows through a path of least resistance. In this case, the water in the pool provides a conductive path for the electricity to travel from the live wire to the swimmer. The swimmer's body is also a conductor, so the electricity can pass through their body and cause a shock. The voltage of the live wire will affect the severity of the shock. A distribution line carries a much higher voltage than a household outlet, so the shock will be more severe. In flood situations, people get electrocuted because the floodwater creates a conductive path for the electricity to travel from the down power lines to the ground. When people stood in the water, they became part of the conductive path and were electrocuted. To avoid getting shocked in this situation, stay away from down power lines. If you see a live wire in the water, do not go near it and call 911 or your local emergency number. The distance from the live wire does not matter. As long as the water is conductive enough, the electricity can travel through it and shock. The presence of other swimmers in the pool can also increase the risk of a shock because the more people there are in the water, the less resistance there is for the electricity to travel. When electricity enters water, it disperses, but not in a uniform way like ripples in a pond. Instead, it follows complex paths determined by conductivity. The voltage decreases as you move away from the source, but the rate of decrease isn't linear. There will be voltage gradients. This means there are areas of differing electrical potential in the water. The closer you are to the point where the wire enters the water, the higher the voltage and the greater the risk. The current will flow through the water, seeking the path of least resistance back to its source. Your body, being a relatively good conductor compared to the water, can become that path if you are in the vicinity. The amount of current that passes through your body determines the severity of the shock. Even a small amount of current can cause muscle contractions, making it difficult to swim or even breathe. Larger currents can lead to ventricular fibrillation, cardiac arrest, and death. The voltage necessary to cause a dangerous shock depends on several factors, including the condition of your skin, the presence of any open wounds, and the duration of the exposure. Wet skin significantly reduces the body's resistance, making you more susceptible to electric shock. A 110-volt circuit can be lethal under the right circumstances. Distribution lines carry much higher voltages, often thousands of volts. Contact with a down distribution line is almost always fatal. The ground isn't always a perfect conductor. The Earth's resistance varies depending on the soil type, moisture content, and other factors. This means that the current from a down power line will spread out through the ground, creating a voltage gradient. If you're standing on the ground near a down power line, you could become part of the circuit, even if you're not touching the wire directly. This is known as step potential, which is the voltage difference between your 2 feet. The greater the distance between your feet, the greater the voltage difference and the greater the risk of shock. If you're near a down power line, keep your feet together and shuffle away to minimize the step potential. In a flooded area, the water acts as a conductor, spreading the current over a wider area. This can create a very dangerous situation, as the water may be energized even if you're not near a visible power line. Never enter floodwaters if there's any possibility of down power lines in the area. Electricity always seeks the path of least resistance. If you provide a better path than the surrounding water or ground, the current will flow through you. This is why it's so important to avoid contact with anything that could be energized, including metal fences, trees, and even puddles. Electricity and water are a deadly combination. Always be aware of the potential hazards and take precautions to protect yourself. Remember, stay away from down power lines, never enter floodwaters if there's a risk of electrical hazards, and call for help immediately if you see a dangerous situation. Consider the conductivity of the water, because pure water is a poor conductor of electricity. It's the impurities in water, such as salt and minerals, that make it conductive. Swimming pools typically contain chlorine and other chemicals that increase their conductivity. Seawater is highly conductive due to its high salt content. The human body's resistance to electricity varies dependent on several factors, including skin dryness, contact area, and the individual's physical condition. Dry skin has a much higher resistance than wet skin. A small cut or abrasion can significantly reduce the body's resistance. People with heart conditions or other health problems may be more susceptible to electric shock. The severity of an electric shock is determined by the amount of current that passes through the body, the path of the current, and the duration of the exposure. Even a small amount of current, such as 1 mA, can cause a tingling sensation. Currents of 10 mA or more can cause muscle contractions. Currents of 100 mA or more can be fatal. The path of the current through the body is also important. If the current passes through the heart or brain, it's more likely to be fatal. The longer the exposure to the current, the greater the risk of serious injury or death. Electrical safety is a serious matter. It's important to be aware of the potential hazards and take precautions to protect yourself and others. If you're not sure whether something is safe, err on the side of caution. Call a qualified electrician or your local utility company for assistance. Always assume that any wire is live, even if it appears to be down or broken. Never touch a downed power line or anything that's in contact with it. Stay at least 10 feet away from downed power lines. If you see a downed power line, call 911 or your local emergency number immediately. Warn others to stay away from the area. If you're in a car and a power line falls on it, stay inside the car unless it catches fire. Call 911 or your local emergency number for help. Wait for the utility company to de-energize the power line before you exit the car. If you must exit the car because of a fire, jump clear of the car and land with your feet together. Shuffle away from the car to avoid step potential. Never try to rescue someone who's in contact with a live wire. You could be electrocuted yourself. Call 911 or your local emergency number for help. Turn off the power at the breaker box or main switch if it's safe to do so. Use a non-conductive object, such as a wooden stick or broom handle, to separate the person from the live wire. Begin first aid and CPR if necessary. Electrical safety is everyone's responsibility. By being aware of the potential hazards and taking precautions, you can help prevent accidents and save lives. The question highlights two specific scenarios. Firstly, a person swimming in a pool with a live wire falling in, and secondly, people being electrocuted in flooded streets due to downed power lines. Each of these scenarios presents unique electrical hazards. In the swimming pool scenario, the water becomes energized when the live wire falls in. The electricity spreads through the water, creating a voltage gradient. The person swimming in the pool becomes a potential path for the current to flow back to its source. The severity of the shock depends on the voltage, the distance from the wire, and the conductivity of the water. Even if the swimmer is not touching the pool's edge, they can still experience a shock. In the flood scenario, the water acts as a conductor, spreading the electricity over a wider area. People walking or standing in the water become part of the electrical circuit. The fact that they have their legs on the ground increases the risk of electrocution, as it provides a direct path for the current to flow through their body to the earth. Proximity to the fallen line increases the risk, but even people who are farther away can be electrocuted if the water is sufficiently conductive. Therefore, it is not just the contact with the ground or the proximity to the fallen line, but a combination of both factors that leads to electrocution in flood situations. It is important to remember that the ground itself can become energized near a downed power line. This is due to the ground resistance, which causes the current to spread out and create a voltage gradient. This means that even if you are not in direct contact with the downed line, you can still receive a shock if you are standing in the vicinity. The voltage is a critical factor in determining the severity of an electric shock. A 110-volt shock can be dangerous, but a distribution line carrying thousands of volts can be lethal. Therefore, it is essential to stay away from downed power lines regardless of the voltage they carry. Electrical codes, such as the National Electrical Code, or NEC, provide guidelines for safe electrical installations and practices. These codes are designed to minimize the risk of electric shock and other electrical hazards. Understanding and following these codes can help prevent accidents and save lives. Grounding is a safety measure that helps protect people from electric shock. Grounding provides a low-resistance path for the current to flow back to its source in the event of a fault. This helps to trip the circuit breaker or fuse, which cuts off the power and prevents a dangerous shock. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to detect ground faults, which are electrical leaks to ground. When a ground fault is detected, the GFCI quickly shuts off the power, preventing a dangerous shock. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Regular inspection and maintenance of electrical systems are essential for ensuring safety. Damaged or worn-out wiring can create a risk of electric shock or fire. Overloaded circuits can also be dangerous, as they can overheat and cause a fire. It is important to have electrical systems inspected regularly by a qualified electrician. The first step to take when you encounter a downed power line is to stay away. The minimum safe distance is 10 feet, but it is best to stay as far away as possible. Call 911 or your local emergency number immediately. Do not attempt to move the downed power line yourself or touch anything that is in contact with it. Warn others to stay away from the area. If you are in a car and a power line falls on it, stay inside the car unless it catches fire. The car's rubber tires provide insulation from the ground. Call 911 or your local emergency number for help. Wait for the utility company to energize the power line before you exit the car. If you must exit the car because of a fire, jump clear of the car and land with your feet together. Shuffle away from the car to avoid step potential. Never touch another person while you are in contact with a live wire. You could become part of the circuit and be electrocuted. Use a non-conductive object, such as a wooden stick or broom handle, to separate the person from the live wire. Begin first aid and CPR if necessary. The distance from the live wire does not matter. As long as the water is conductive enough, the electricity can travel through it and shock you. Also, the presence of other swimmers in the pool can also increase the risk of a shock. This is because the more people there are in the water, the less resistance there is for the electricity to travel. When a live wire falls into a pool, the water becomes energized and the electrical current will spread throughout the pool water. The voltage will be highest near the point of contact with the wire and decrease as you move away. However, even at a distance, the voltage can be high enough to cause a serious or fatal shock. The human body is a good conductor of electricity, especially when wet. When a person enters the pool, they become part of the electrical circuit, providing a path for the current to flow through their body back to the source. The severity of the shock depends on the amount of current flowing through the body, which is determined by the voltage, the person's resistance, and the path of the current. The voltage of the live wire is a major factor in determining the severity of the shock. A standard 120 volts household circuit can cause a painful shock and even be fatal under certain conditions. A distribution line which carries thousands of volts can cause immediate death. People got electrocuted in flooded streets in Bombay and other places because the floodwater created a conductive path for the electricity to travel from the downed power lines to the ground. When people stood in the water, they became part of the conductive path and were electrocuted. The water acted as a conductor, spreading the electricity over a wide area. This made it possible for people to be electrocuted even if they were not near the downed power lines. The fact that people were standing on the ground also increased the risk of electrocution, as it provided a direct path for the current to flow through their body to the earth. To avoid getting shot in this situation, it is important to stay away from downed power lines and flooded areas. If you see a downed power line, do not go near it. Call 911 or your local emergency number. If you must walk through floodwater, try to avoid contact with the ground. Wear rubber boots or other insulated footwear. The purpose of grounding is to provide a safe path for electrical current to flow in the event of a fault. This helps to prevent electric shock and other electrical hazards. The ground wire is connected to a metal rod that is buried in the ground. This rod provides a low resistance path for the current to flow back to the electrical panel. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. They work by monitoring the current flowing through a circuit. If the current flowing through the circuit is not equal to the current returning, the GFCI will trip, cutting off the power to the circuit. This can happen if someone touches a live wire or if there is a ground fault in the circuit. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Electrical safety is an important issue that should be taken seriously. By following these tips, you can help protect yourself and others from electric shock.